Hello, I'm Edward Chang. I'm a neuromuscular massage therapist from the state of California, and here I'm going to be explaining a concept called physics. Now, I know a lot of you have been asking me a question about, oh, why are you working there, but my pain is over here, and why are you jumping over there? And there's a myriad of reasons for it. But one of the biggest concepts I think helps kind of explain that is a concept in physics. And this is something that a lot of massage therapists have been asking me questions about because it's one of the biggest concepts that I use. And a lot of massage therapists, when I was in school and when I got out of school, this was the biggest thing they wanted to learn. And it was very difficult because I was like, I can't teach a physics in a single 10-minute session. I can't do this. But this is exactly what I'm using. It's physics. Now, physics is a huge course and it has a lot of material in it. And I'm going to go show you the tippity top of the physics and what we're doing in physics. But there's a lot more to it, and that's exactly what I'm using all the time. So let me go ahead and get started. Let's go ahead and start with a little bit of an object, and hopefully you can see this nice and clearly. There's a little bit of an object. Okay, here we go. You have a box, you have an object. Now, how are we going to move this object? Well, obviously, we're going to have to apply a force to this object. So let's go ahead and draw that force out. So here we're going to draw a force, and it's represented by this arrow. Where is this object going to naturally move? Simple. There's one arrow, there's one force, it's going to move that way. There's no question about it. It's going to move that way. Right? There's no question. Here's another arrow. Now which way is this object going to move? Go ahead and try it yourself. Put an object on the table, push it from the bottom, push it from the side. Where is it going to go? Let me go ahead and get a different color. Whoop. That's not good. That's not even a good arrow. Okay, there we go. That's the way the object's going to move, right? It's going to move sideways. It's going to move sideways and up. It's going to move diagonal. And that's basically where the object is going. Pardon. That's where the object is going. So in physics, what we do is we look at this all the time. And we basically look at these force vectors and calculate where's the object going to go, how far, and how much. And we calculate this all the time. Now in physics it gets a lot more complicated, and the situation gets a lot more sticky because we're not just dealing with the x and y plane. We're not just dealing with to the side and from the top and the bottom. We're not dealing with left and right and top and bottom and just that. There's a lot more we start dealing with. We start dealing with water and buoyancy and three-dimensional forces. I mean, just imagine having a little hanging water bottle. There's so much things going on when we start pushing from not just the top, the bottom, and the sides. Now we're talking about pushing from the front and the back. And then we have torque, forces that circle around, because if you push that water bottle, I'm gonna bet you it's going to start circling around. And we're starting to deal with a lot more forces and a lot more things. And that's what your physics course is about. It's just calculating all of that at once. Calculating all this stuff. And this is what we study in physics. It's a huge topic. Huge. And I just covered the very tippity top of the entire thing. I mean, it gets into a lot more detail really, really quick. We start graphing these. We start graphing these and start calculating these arrows, and that's what happens. I'm sorry. I'm pointing to something and that doesn't exist, but you know what I mean. So that's what we do in physics. Now, what does it mean in terms of your body? So let's go ahead and say, for a very simple example, that you have your arm, right? Here's your one bone of your arm, and there's two additional bones in your forearms. I'm not going to name them because that's going to overcomplicate things. So here's your arm. Let's say that someone's going to go ahead and try to pull your arm apart. Now, we know that this here would be the joint, right? Your elbow would be right here, right? And then your shoulder would start somewhere here, and we'd have a whole bunch of other bones, and there's you and your head. That looks so weird, but you got what I mean, right? Here's you, your head, and here's a bunch of bones there. Don't worry about it. So let's go ahead and pull your arm. Let's say that someone's trying to pull your arm that way, and they're pulling very, very hard. They're trying to pull you apart, basically. What's going to happen is they're going to put strain on this joint. And what's going to happen is those muscles that are attached to these bones are going to try to keep this joint together. Your muscles are responsible for movement of this joint, and they can restrict the movement or cause the movement. And so these muscles are basically going to be acting in order to balance out this force, and they're going to try to create a resultant force that goes this way. Right? They're going to try to create a force this way to make sure your arm doesn't come apart. That's basically what I'm doing. Is I'm looking at these diagrams in terms of those joints, and let's pretend those joints, that joint is now the object. And I'm basically calculating the forces on this joint from every single direction and trying to make sure this joint doesn't come apart. And that's what I do. Now, I'm not saying that the joint is going to come apart or it's liable to come apart if you're sore or anything like that, or if you're having pain. It's not that doesn't mean that it's going to come apart. But it's just meaning that, you know, that's what's causing the pain. It's because there's an imbalance of forces on the joint, and one muscle is working a little too hard, and because it's working overly hard, it's pushing on the nerve, and that's where your pain is coming from. And sometimes, no matter if I work an hour, 2 hours, 3 hours even, on the spot that you say it's hurting, it doesn't matter. It doesn't make any sense because there's more joints. One joint can affect another. It's like dominoes, right? You're not one joint. You're many joints, and you got many muscles. And imagine if I'm affecting my elbow here, my shoulder is going to get affected too, right? Because if I'm pulling here and my elbow is not able to maintain itself, then these muscles here are going to have to work extra hard to pull me back this way. And that means if I'm pulling extra hard this way, that this joint is now going to be affected. And then I'm working on all these joints and working at all this and looking at the huge picture and trying to piece it all together and looking at all these forces to try to make sure that all these muscles are going to pull each other just the right amount. And that's why I'm working in areas that you're thinking, why is he working there? Because no matter how much I work on it, it's not going to get better. Because some force is somewhere else is keeping you from relaxing that area. And no matter what I do, it's not going to relax until I relax the other area. Because it's trying to keep itself together. Your body is very good at that. So hopefully this kind of explains why I do what I do. And it's all about this. It's all about vector forces. That's what we call them in physics. It's about the vector forces. And we're calculating this and we're dealing with this. And that's what I do. Is I'm taking all that years of physics I've had and I'm applying it to your body. And that's what your physicians are doing as well. And this is why, in case you're taking your pre-medicals and like, why is physics important? This is why. This is why. It's one of the most important topics that you could ever take for your pre-medicals, and it's essential to know. So hopefully that helped. And I will be answering a bigger question. So stay tuned and hope to see you next time.